Hello, welcome to Open Source CNC. Here we create toolpaths in FreeCAD and Blender and we turn them into real objects on the CNC. Today we are going to model, make the toolpath and mill on the CNC this cube. This cube is a replacement part for a hanging light. It seems pretty easy, but it has some challenges because the pocket is very deep and I had to adapt the toolpath in order to be able to mill that with the toolbits that I had lying around that don't have such a long cutting edge. In this video I will show you how to first model the object in the part design workbench in FreeCAD. I will show you how to make the toolpath to flatten the stock to bring it to the required dimension. After that we will create the operations to mill this pocket using two stages, one with a larger toolbit and one with a smaller toolbit. The next step is going to be milling the holes, the round holes, using a Helix Operation, and in the end we are going to mill the outline, the profiling of the object to get the shape that we want. If you need personal guidance, be it in FreeCAD or in Blender, I offer one-on-one online sessions where we can go through your projects, troubleshoot them, or speed things up. You can find the link in the description of the video. And if you would like to support me, you can do that through my Patreon page. You will also find the link in the description. Any contribution helps me a lot to keep doing this free series. Throughout this video, I will be using FreeCAD 1.1 development version. It will soon turn into the stable version, so that's why I'm using it. I do the modeling in the part design workbench, and the first thing that I'm going to do is create a new body. To define the shape of the body, I'm going to use a sketch. A sketch is a 2D drawing that represents the projection of the object that I want to create on one of the planes. So I'm going to create a new sketch and I'm going to use the XY plane. Since I'm building a rectangular box, I'm going to define the top projection, which is going to be a rectangle. After selecting the tool from the toolbar, I will make a first click, move the mouse and make a second click in order to define the overall shape. To perfectly determine where the shape is positioned and its dimensions, I'm going to use constraints. First, let's make it start from the origin by selecting the bottom left corner and the origin and pressing the C key, which is a coincident constraint. This means that these 2 points will always sit on top of each other. This box is going to have a square base. In order to achieve that, I'm going to select 2 perpendicular lines and press the E key, which means these 2 lines will always be equal. The final step to get this shape perfectly determined is to give it a dimension. I can select any of the lines, for example this one, press the I key to give a vertical distance constraint, and in the pop-up box I'm going to write the dimension of 140 millimeters. I can now close the sketch because it is fully constrained. You can see it here written, or you can take a look at the shape and see all the lines green. After creating the projection and setting all the constraints for it to be perfectly determined, we need to turn the sketch into a 3D object. For that, we are going to use the path button. Here I have to give it a length. In my case, it's going to be 60 millimeters. And now I can click on the OK button to close the dialog, and I have the 3D object ready. Well, not ready because I just have a box. We still need to make a square hole in the center, and then we are going to make round holes for the cable to pass through. To make the rectangular hole in the center, I'm going to select the top face and create a new sketch. This time the sketch is not going to define a path but a hole. Again, select the rectangle tool, click the first time, and now before clicking for the second time, I'm going to use these dialog boxes that appear on screen in order to give it dimensions. The inner rectangle is going to be 110 millimeters. Press the tab key and also set the same value for the vertical. Press enter, and now the rectangle is perfectly determined. The last thing we need to do is to position the rectangle. Let's select the bottom left corner, press the L key to set a horizontal distance. Let's type 15 millimeters here, and then I will do the same with the same point, but this time I'm going to use the I key to set a vertical distance constraint, set to 15 millimeters. The sketch is green. I can see here the fully constrained message, so I can close it, then use it to make a hole using the pocket tool. I need to set a length, which in my case is going to be 54 millimeters because I want the bottom of the box to be 6 millimeters thick. Press on the OK button. After creating the overall shape and the main pocket, we still need to make the 4 holes in the base, and as you imagine, again we are going to use a sketch. This time I'm going to place the sketch on the bottom face, so select it and then click on the new sketch button. Let's make one circle here. After drawing it, we need to set its constraints. First, let's select the outer line and press K then R to set a radius. I'm going to use 5 millimeters for the radius, Positioning is done by setting the distance for the center of the circle. So let's press L for a horizontal distance. I'm going to use 35 millimeters. And then select the center again, press I for a vertical distance, and I'm going to use a minus 70 millimeters, so it sits in the center. The circle is green, I can close the sketch. I'm going to use this circle to create a new hole in the base, so again select the pocket tool, but this time instead of setting a length, I'm going to change the type of the hole from dimension to through all. This means that the hole will pass through all of the features of the object. We now need to turn this hole into 4 holes arranged in a circle around the center of this face. In order to do that, I'm going to use the polar array, but before creating the polar array, I'm going to use this tool here, which is the datum line, because I want to have a reference axis around which we are going to rotate the object. Let's select the bottom face, and as you can see, I have this axis which is perpendicular to this face by default. This is a particular case because this face has a regular shape. If the face was a little bit odd and I wanted to set a different rotation center, I can always use the attachment offset in each of the directions. But for this situation, this suits perfectly, so I can click OK. Now let's select the pocket, use the polar array tool, and instead of the normal sketch axis, we are going to select the reference, rotate the view, hover the mouse over the datum line, click on it, and now as you can see, the holes are around this line. We need 4 occurrences and let them be all around. Let's use a length of 360 degrees. Click on the OK button. We have the object almost ready. I have the 4 bottom holes. Let's hide the datum line by clicking on this little eye icon. And we still need to do one more thing. Hold Ctrl to select these 4 corners. And let's create a fillet with a radius of 3 millimeters. In the CAM workbench, let's start creating the job, which is the overall environment that we are going to use for our operations. Let's select the object that we want to mill and create a new job. Make sure it is selected in the list, click on the OK button, and now I have a dialog here. Let me expand this a little bit, where we are going to set everything in order to get the correct results. By default, the stock is set as an extended models bounding box, which I'm going to use, but I'm going to change all the extensions at both ends of all the 3 axes to 0 millimeters. Once I've set the extensions to 0, I can zoom in, click on this little dot here in the corner, and then click on the Set Origin button, so the origin will be in this upper left corner. The second step in creating the job after setting the stock and the origin is adding the toolbits that we are going to use. Let's go to the Tools tab, click on the Add button, and select the toolbit that we are going to use from this list. I have a list of predefined toolbits here, but what if I don't have the toolbit? Let's click on the Cancel button, go to the CAM menu, and to Toolbit Library Manager, where we are going to create a new toolbit. After clicking on this button, I will have another pop-up window where I have to select the shape of the toolbit. We are going to use an end mill, so let's click on the shape. And now I have a new toolbit here with some default values that we need to change. We can do that by double-clicking on the toolbit, and let's set a label for it. Let's set a 7 millimeters end mill, and let's set all the values that we want in order to correctly represent the toolbit that we are going to use. A cutting edge height of 40 millimeters, a diameter of 7 millimeters, a length of 60 millimeters. This is the overall length. If you don't know exactly what these values represent, you can see here a letter, and in the drawing you will see exactly what each letter represents. The shank diameter is going to be 6 millimeters, and I can also set a chip load, even though for now it doesn't affect how everything works. Click on the OK button, and now I have the new 7 millimeters end mill, which I can use in the job after closing the library manager. Click on the Add button, and now as you can see I have the 7 millimeters end mill here. I'm going to use a 5 millimeters end mill, not the 7 millimeters end mill that we have just created. I've only created that to show you how to create a new toolbit in case you don't have the one that you need. Click on the Add tool, and you can see it here in the list, the 5 millimeters end mill. All the values in this table can be modified by double-clicking on the field, but what is important is setting the horizontal feed speed, which is the movement on the X and the Y axis. I'm going to use a value of 1500 millimeters per minute, the vertical speed, which is the movement on the Z axis, and the spindle speed, of course, the rotation speed, 20,000 RPM. I can now remove the default toolbit. It's a safe practice in order to avoid using it by mistake. And let's add the other two toolbits that we are going to use. A 10mm end mill. Set its speeds. This time I'm going to use higher speeds. Let me just expand this a little bit, because I'm going to use the 10mm end mill to remove most of the material in the pocket so it can move as fast as the machine can handle. And the last toolbit that I'm going to use is the Facing Toolbit, for which I'm going to use a speed of 1500 millimeters per minute and the vertical speed of 1000 millimeters per minute with a spindle speed of 19,000 RPM. Once the toolbits are added, I can just click on the OK button and close the job. I can create operations and everything will work. But I want to set a few more details in order to get correct operation times, and that is the default values, which are the rapid speeds. These are purely informative. They are not going to affect how the machine will move, but I know that my machine moves with 6500 millimeters per minute on the horizontal and on the vertical axis, and I will change them accordingly. This will help calculate the correct time after creating the operations, so I know how much each of the operations will take. In the Output tab, I'm going to select the proper post-processor depending on the machine. In my case, it's a GRBL controller, so I can leave it just as is. And if I want, I can set an output file, which I'm not going to do now. And this means that each time I'm going to export the job, it will ask me for a file name. So let's click on the OK button, and we are done creating the job, setting the stock, adding the toolbits. We can now move on to creating the operations. Now let's flatten the stock. We are going to use a stock a little bit bigger than what we want in the end, so we'll need to make a facing operation. I will select this top face and click on the face operation, select the proper toolbit, which is a facing small toolbit, click on the OK button, and here I will be able to set everything in order to get the operation exactly as I want. Before setting anything, I will click on the apply button to see what is the default behavior. You can see it here. It's pretty odd. It only moves inside this face. Let's change some settings in order to get the correct milling operation, to get the entire face of the stock milled flat. I will leave the pattern as a zigzag, but I will change the angle from 45 degrees to 0 degrees in order to have the movement along the x-axis, which is the most stable axis of my machine. After clicking on the apply button, you can see now the movement is along the x-axis. I will also change the material allowance. I will use a value of 20 millimeters. What this does is expand the area that is going to be milled with 20 millimeters. And this means the cutter will surely mill everything flat. It won't leave any spaces at the corners or at the ends when it's turning around. There's one more thing that I want to check before closing the operation, and that is the step down in the depth tab. The default step down in any operation in FreeCAD is equal to the diameter of the toolbit. In my case, I have a very large toolbit, a 34.9 millimeters toolbit, and that is way too much for such an operation. So I will click on this little icon, the F icon, click on the reset button, and now I can manually type here a step down of 2 millimeters. This won't affect the operation that I'm creating because it only has one pass, but in case I want to make several passes, changing this value is very important. Click on the OK button to close the operation, and now let's move to the machine to see how everything turns out. To get the G-code and import it into Universal G-code Center and run it on the machine, I have to select the job, click on the post-process button, and I will have a pop-up with the G-code. Click on the OK button, and now I can save the file and open it in Universal G-code Center. So let's see how the machine behaves using the G-code generated in FreeCAD. Now that I have the stock flat, let's select the operation, click on the toggle operation button, which will disable it. And now let's create the pocket, the holes, and then the profiling. In the beginning of the video, I was telling you that I'm going to have a few challenges. One of them is the pretty large depth of this pocket. This is a 54 millimeters deep pocket, which first has a problem because the tool bit that I'm going to use doesn't have such a long cutting height, so I will have to somehow solve that. And I will also have some problems with removing the chips, but for that I will rely on blowing air into the hole to remove the chips as soon as they are cut. As you've seen when creating the job, I've added 3 toolbits: the Facing toolbit that we have already used, a 10mm toolbit, and a 5mm toolbit. We are going to use the 10mm toolbit to remove most of the material in this pocket, and then we are going to use the smaller 5mm toolbit to get smaller corner radiuses and to get to the bottom because the 5mm toolbit is much longer. Let's select the bottom of the hole and click on the pocket operation button. First click apply to see what happens. Well, we have to change a lot of things. First, let's change the tool controller because by default when creating an operation, FreeCAD will use the toolbit that we have used for the last operation. In this case is the Facing toolbit, which I don't want to use for this. Let's use the 10mm toolbit. But the toolpath is still not what I want to get, and that is because it will avoid these holes. In fact, I want to cut the material above these holes, so I'm going to use this checkbox here, use outline, which will ignore any hole in the face. I'm also going to change the pattern from offset to zigzag offset. I will tell you in a few minutes why, and change the angle to 0 degrees because my machine is the most stable when moving along the x-axis. Now you can see the new toolpath. One more thing to change is the step over percent. I will use a value of 95%. Since this is just material removal, I will use a step over as high as possible. But my toolbit cannot reach the bottom of this pocket. The collet will hit the sides. It doesn't have such a long cutting edge. It only has a 27mm cutting edge. Let's fix this by making it stop before it reaches too deep. Let's go to the depth group, and here I have several values, which is the start depth, the final depth, and the step down. Of course, the step down is too big. Again, it's equal to the tool bit diameter, so let's change the formula. I will use a step down of the tool diameter divided by 4, which means you can see here it's a 2.5mm step down. Click somewhere else to make the field update. Now if I click on the apply button, you can see that I have a lot more layers, but they still reach the bottom, which won't be possible on the machine. Let's change the final depth so it stops when the cutting edge of the tool bit ends. Again, click on the formula, click on the reset button, and let's set a final depth of minus 27mm. You can see in the 3D view that now it stops when the cutting edge ends. Let's click on the OK button to close this operation. And now let's make the next operation, which will continue milling, but with a little trick. Select the previously made operation, click on this button, which will copy it. We'll create a new operation with exactly the same settings. Double click on the new operation and let's go to the pass extension field and set a value of 0.1mm. Going to the depth tab, let's set a start depth by resetting it and setting it to minus 27, so it starts where the previous operation ended, and set a final depth of minus 44mm, which is the deepest this toolbit can reach. Clicking the apply button will add the toolpath for this operation. You can see it starts where the last one ended and goes down to minus 44mm. What is different about this toolpath? Let me just set the view from the top and set an orthographic view so you can easily see what I want to explain here. Zooming in, you can see that the toolbit is going inside in the pocket with 0.1mm, the value that we have set here at the pass extension field. This means that the part that is not active, is not cutting, won't touch the walls, so it won't leave burning marks or damage the toolbit. I can close this operation now, and I almost have all the pocket milled. I still need to do one more operation, which is going to be the clearing with a 5mm toolbit. Since I'm going to use almost all the settings exactly as for the 10mm toolbit, let's again copy the operation, Double click on it and let's change only the things that we need to change. The tool controller, the 5mm tool bit. In the depth tab, I'm going to change the final depth to -54, which is the depth of this face. The start depth will be 0mm. I want it to start from the top. Why do I want to start from the top? Because at these corners, the 10mm will leave a pretty large radius. Making another pass with a 5mm tool bit will remove most of that material, making the inside corners as tight as possible. Let's also change the step down because now I have a quarter of the tool diameter. Changing the tool diameter means the step down will be too small. So let's click on the reset button and set a manual step down of 1.5mm. It's pretty obvious that there was no point in removing all that material with the 10mm tool bit. Since the 5mm tool bit is making all these passes, it will take a lot of time, so let's make it work much faster. Scroll up to the Operation Setup tab and let's check this option, the Rest Machining option. Click on the Apply button and now you can see that it only cuts the corners. This is why I've set up a zigzag offset earlier, because if you set the pattern to offset for the previous operations, this won't work correctly. So remember, whenever using rest machining, don't use the offset pattern because you will end up with some weird behavior, some weird movements, which you really don't want to have in your file. After closing this operation, I can export the G-code, but I have one problem. My machine doesn't have an automatical tool changer, so it means that I have to export this in separate files, one for the 10mm tool bit and one for the 5mm tool bit. In order to get the result, let's double click on the job, go to the Output tab, change the order by to Tool and check the Split Output button. After closing the job and recomputing everything, I can now select it and click on the Post-Process button, which will create two separate G-code files, one for the 10mm toolbit with all the operations that use that toolbit and one with a 5mm toolbit. Now that we have milled the pocket, everything looks okay. Let's select all these three operations, disable them, and let's create a Helix operation to mill the 4 circular holes in the bottom. Click on the Helix button, scroll down to the base geometry and make sure that for the base geometry you have the 4 holes automatically detected as they should be. And if I click on the Apply button, you can see the G-code to mill these holes. Let's improve it a little bit because it starts from the top of the stock, which is already removed, so I don't want that. Let's select one of the circles at the top of the holes, scroll up to the Depth tab, and click this arrow next to the start depth value. Now you can see that it will only start from this depth. I still want to do something. Change the step down, click on the Reset button and change it to 1mm. Just to make sure the long 5mm toolbit won't be deflected by a too high step down and the holes will have the proper diameter. Let's close this operation. Again, select the job, click on the Post-Process button. first disable the Helix operation. And now let's create a new profile operation. I don't have to select anything because the profile operation will by default cut the entire outline of the object. Let's first click on the apply button to see the default behavior, which is pretty good, but we still need to make some adjustments. The step down, which is by default 5 mm, let's use a step down of 2.5, which means half of the tool diameter. And this should do it, but I have two more problems. First, the same problem because I have a very tall wall here, a 6 centimeters, 60 millimeters wall, and I want to split this operation into two. Again, let's set the final depth by clicking on the reset button and set a final depth of -30. This is the cutting height of the tool bit, of the 5 mm tool bit. And now it stops here. But I also want to remove some extra material around the cutout because the stock that I'm using is a little bit larger and I will have some material remaining around these two edges, which means I might end up with some flying pieces. That's something that I really don't want. And here is a great new feature in FreeCAD 1.1, which is the number of passes for the profile operation. Let's set a number of passes of 2. Click on the apply button. Nothing has changed because I haven't changed the pass step over. I'm going to use a value of 3 mm, and this means it will make, let me just set a top view, it will make another pass 3 mm outside the object. You can now see the two passes, and what you need to know is that it will first make the outside pass and just after that it will go around the object. Let's click on the OK button, and now let's duplicate the profile operation. Double click on it again. Let's set an extra offset of 0.1 mm, just as we did with the pocket operation. We want it to cut slightly outside of the object so it doesn't touch the wall here with the part of the tool bit that is not cutting. And I want to do that because otherwise it will rub against the material and it will heat up, it will leave burn marks on the material and the tool bit might break. But it's still cutting at the same height because I haven't changed the start and the final depth. Let's set it to start at -30 where the previous operation ended. And let's set the final depth of -60, which is the bottom of the object. Let's set a top view to make sure I have these two passes slightly to the outside. They are correctly placed, so I can close this. And let's see how it turns up in the end. Thank you for watching. I hope this video was useful. And remember, if you need one-on-one guidance, you can find the link in the description of the video, be it FreeCAD or Blender. We can meet online and troubleshoot your projects. Also, if you want to support me to keep doing this free series, you can do that by subscribing to my Patreon page. All the help counts, so thank you everybody for supporting me and see you next time for the next video.